14:23 local time, a Ukrainian Su-27 skimmed just 60 meters above a river valley, flying fast and low toward a Russian-controlled dam. Destroying this dam was critical. It would choke off Russian supply routes and slow reinforcements moving toward the front. The flight had been routine until it wasn't. Without warning, the pilot's radar warning receiver RWR screamed to life, emitting a harsh, continuous tone that meant only one thing: missile in the air. He had maybe 18 seconds before detonation. The pilot slammed the stick right, pulling 7 Gs as he dove into the narrowest part of the valley. Above him, a missile was already descending from 8,000 meters, riding a ballistic arc. In 14 seconds, its seeker would go active. In 16 seconds, it would pass directly overhead. He pushed negative Gs and dove toward the river surface, using every centimeter of terrain masking available. Water spray exploded upward as the jet bottomed out at 40 meters. The RWR flashed again, then again. Second launch, third launch. A Russian Buk surface-to-air missile battery was firing everything it had at the valley exit, the point where their computers predicted the Su-27 would appear. But they had made one critical mistake. They were firing at where the jet should have been, not where it was. The 9M37 missile uses a 2-stage guidance system. For the first 80 of its flight, it navigates purely by inertial guidance toward a predicted intercept point. Ground radar sends course corrections every 0.5 seconds, but those corrections depend entirely on radar track quality. When track quality drops below 60, the corrections become educated guesses. And when an Su-27 is pulling 7 Gs at 40 meters, hidden behind terrain, track quality collapses to around 15. This is where the Su-27 thrust-to-weight ratio of 1:9 became decisive. Unlike older Soviet designs, the aircraft could sustain high-G maneuvers without bleeding energy. The pilot rolled inverted, pulled through a split S, down to 20 meters, then immediately reversed into a climbing barrel roll, peaking at 300 meters. Each maneuver forced the missiles to recalculate their intercept geometry. Then the first missile seeker went active. The pilot had 3 seconds. He rolled 120 degrees right and yanked the jet into a tributary valley branching north. The missile seeker swept through empty air, where the aircraft should have been. With no target, it defaulted to impact fusing and detonated 400 meters behind the Su-27. The second and third missiles met the same fate. Their seekers couldn't see through terrain. By the time a fourth missile arrived, the Su-27 was already 6 kilometers away and accelerating. The Buk battery had emptied an entire launcher for nothing. But the Russians weren't finished. A second Buk launcher, positioned 3 kilometers south, had a better angle on the valley. As the Su-27 crossed a 2-kilometer gap between ridgelines, the fire control radar locked on. Track quality jumped to 75%, good enough for a high-confidence shot. What the Buk crew didn't know was that this Su-27 carried an L-150 Pastel radar warning receiver. It didn't just detect threats, it analyzed them. By measuring pulse repetition frequency, scan pattern, and signal strength, the system calculated the battery's location to within 200 meters. The pilot knew exactly where the missiles would come from. The problem was time. At low altitude, the Su-27's wing loading of 545 kilograms per square meter meant it needed nearly 800 meters to complete a 180-degree turn at combat speed. But it could do something else: climb like a rocket. With a maximum climb rate of 45,000 feet per minute, the Su-27 could gain 9,000 feet in 12 seconds. As 2 more missiles launched, the pilot pulled hard and firewalled the throttles. The jet pitched up at 70 degrees nose high, the twin AL-31F engines, each producing 27,500 pounds of thrust, driving the aircraft skyward. In 15 seconds, the jet climbed 1,500 meters, placing it above the Buk's optimal engagement envelope for low-altitude targets. The 9M317 is optimized for targets below 15,000 meters. When a target suddenly climbs from 60 to 1,500 meters in the terminal phase, the missile's control surfaces can't generate enough force to match the climb rate. The missiles tried to lead, they overshot. Both proximity fuses detected the aircraft, but calculated the missed distance as too great. They detonated 200 meters below harmlessly. The Su-27 had survived again, but the zoom climb came at a cost. Every radar within 100 kilometers now saw him. As the pilot pushed over at 1,600 meters and dove back toward the deck to resume his low-level run toward the dam, a new symbol appeared on the threat display. A Russian A-50U mainstay airborne early warning aircraft had been orbiting 95 kilometers southeast of the dam at 10,000 meters altitude for over 3 hours. Its Shmelem radar could track 300 targets simultaneously, reaching 650 kilometers for high-altitude aircraft and 215 kilometers for low-flying fighters. The Su-27 hugging the river valley didn't appear as a clean track, only fleeting radar returns that blinked in and out every few seconds. But the A-50's operator noticed a pattern. Every 20 to 30 seconds, something disturbed the radar picture. Each disturbance lasted 1 to 2 seconds, moving east at roughly 650 km/h. After correlating 12 ghost contacts, the system calculated a 78% probability of a low-level penetrator following the river network. This is where the A-50 earned its keep. A data link message was transmitted to the nearest Russian fighter, an Su-35 flying combat air patrol 34 kilometers away. Bearing, speed, altitude band, predicted intercept geometry all appeared on the Su-35's display within 7 seconds. The Su-35 pilot pushed his twin AL-41F1's engines to military power, each producing 31,900 pounds of thrust, and turned toward the intercept. Without the A-50's cueing, he would have been searching thousands of cubic kilometers of airspace. With it, he focused 20 kilowatts of radar power into a narrow 10-kilometer slice of terrain where the target had to be. He selected 2 R-77 missiles under his wings and checked the parameters. Target altitude, 400 meters, and descending speed, 780 kilometers per hour aspect, 40 degrees off nose range, 35 kilometers, near perfect geometry for a beyond visual range intercept. And unlike the Buke missiles, the R-77 was far more dangerous. The missile used an active electronically scanned array, AESA, seeker capable of tracking targets 120 degrees off bore sight. Once launched, it didn't need continuous guidance. It would fly most of the way on inertial navigation, then go autonomous and hunt the target on its own. The Ukrainian pilot saw the launch warning and immediately understood the math. He had about 50 seconds before the R-77 seeker went active. That gave him time for one move. He pushed the throttles to full military power and accelerated to 920 kilometers per hour, descending to just 30 meters above the river. At that speed and altitude, the Su-27 was riding the absolute edge of its flight envelope. Any abrupt input could mean a high-speed stall or becoming part of the terrain. Behind him, the R-77 plunged into the valley at Mach 2.8. Its seeker would activate in 20 seconds. The pilot waited. Every second mattered. At the last possible moment, he pulled 5 Gs, simultaneously rolling inverted. The Su-27's exceptional thrust-to-weight ratio allowed it to maintain energy through the turn, while the flight control system prevented a stall despite a 15-degree angle of attack at just 30 meters altitude. The missile's seeker went active and immediately faced a problem. Instead of open sky, it saw a wall of terrain. The Su-27 vanished behind a 500-meter ridgeline at the exact moment the seeker activated, leaving the missile blind in the most critical phase of flight. The R-77's logic computer had to choose, fly over the ridge and attempt reacquisition, or predict the target's path and detonate based on last known data. It chose the first option. The missile pulled up to clear the terrain, adding 3 seconds to its flight time. Those 3 seconds changed everything. By the time the R-77 crested the ridge, the Su-27 had already turned 90 degrees and was accelerating down a perpendicular valley. The seeker swept its 120-degree field of view and found nothing. The missile had 2 seconds of fuel remaining. With no target, it defaulted to backup logic, calculating where the aircraft should have been, and detonated its 22-kilogram warhead at that point. Over 4,000 tungsten fragments expanded outward in a 30-meter radius. The Su-27 was 800 meters away, heading in a completely different direction. The Su-35 pilot launched his second R-77 immediately, but the geometry was already degrading. Range had opened to 42 kilometers, and the target was weaving between valleys. Radar lock broke repeatedly as terrain masked the aircraft. Doctrine demanded the shot. The missile followed the same sequence: inertial flight, seeker activation, target gone. It detonated 600 meters from the Su-27's actual position. The Su-35 pilot considered pursuit, then checked his fuel state. He had been airborne for 90 minutes, with 2,800 kilograms remaining, enough for 20 minutes at cruise, or 8 minutes at combat power. Not enough to chase a target 180 kilometers from base through hostile valleys. He turned away. But the Ukrainian pilot hadn't come this far just to survive. Tucked beneath the Su-27's wing was the real purpose of the mission, a GBU-38 JDAM-ER. Its extended-range wings were folded tight against the bomb body, waiting for release altitude. Even while evading missiles, the pilot had been running the pre-launch sequence. Inside the cockpit, the master arm switch flipped from safe to arm. Power flowed to the weapon. The JDAM's internal GPS receiver began searching for satellites, its antenna pulling signals through the aircraft's skin. Within 8 seconds, it locked onto 6 satellites, calculating its position to within 3 meters. The guidance computer compared that position with the target coordinates uploaded before takeoff, the exact GPS grid of the dam's critical spillway joint. On the pilot's display, the weapon status changed: not ready. Ready, the bomb knew where it was. It knew where the target was. Now it needed altitude. The JDAM-ER could glide 40 kilometers, but only if released from 3,000 meters or higher. The Su-27 was at 1,600 meters and climbing. The dam lay ahead, but something else had found him first. At 2,400 meters, the JDAM's GPS signal strength from satellite 12 collapsed, from 30 dBm to 142 dBm, then vanished entirely. Within seconds, the receiver went from tracking 8 satellites to 3, each showing position errors of 200 meters, far too inaccurate for the target. This was the work of the Russian R-330ZH JDAM electronic warfare system protecting the dam. It wasn't just broadcasting noise, it was transmitting false GPS signals that looked authentic but carried corrupted timing data. A GPS receiver needs precise timestamps from at least 4 satellites. A timing error of 1 microsecond translates to a 300-meter position error. But what the Russians didn't know was that Ukrainian Su-27s had been modified with selective availability anti-spoofing modules. These compared incoming signals against encrypted military code civilian jammers couldn't replicate. While the JDAM's commercial receiver struggled, the aircraft's military GPS maintained a clean lock. The pilot watched both displays. The bomb thought it was 400 meters north of its real position. The jet knew exactly where it was. The question was whether the JDAM would accept a correction this late. Its software rejected large changes after release, but it would accept one final update before launch if the correct authorization code was entered. As the aircraft climbed past 2,900 meters, jamming intensified. The JDAM system had detected the jet's emissions and focused all 4 antenna arrays on it. Output power surged from 100 watts to 500 watts, completely overwhelming the bomb's receiver. But the pilot had planned for this. He was flying a precise profile that placed the aircraft in a narrow null zone in the jamming pattern at exactly 3,000 meters. The JDAM's antennas were optimized for low-altitude coverage. Above 3,000 meters, a brief gap existed. The altimeter ticked up 3,000 meters. The military GPS display snapped to life. 8 satellites locked, position accuracy 3 meters. The pilot entered the authorization code. The JDAM accepted the update. He pressed the pickle button. The bomb released cleanly and fell away. 4 minutes and 12 seconds later, it would either strike the dam's critical structural joint, or everything would have been for nothing. The moment the JDAM-ER cleared the pylon, a silent mechanical sequence began. Spring-loaded actuators fired, 4 wing panels snapped outward, rotating 90 degrees and locking in place in less than a third of a second. The tail fins followed, unfolding to give the guidance system full control authority. In half a second, the weapon transformed from a blunt steel cylinder into a 6-foot wingspan glide bomb. Then the GPS went dark. Russian jamming overwhelmed the receiver almost instantly, but it didn't matter anymore. Those final seconds of clean data had been enough. Inside the bomb, the inertial navigation system took over. Ring laser gyros and ultra-sensitive accelerometers tracking every movement with ruthless precision. The JDAM glided silently. 2,000 meters. 1,000. 500. Wind pushed it slightly northeast, but the guidance computer compensated, making tiny corrections every tenth of a second. It didn't need perfection, only to stay inside the planned impact box. At 200 meters, the bomb entered terminal dive. The nose pitched down to 73 degrees. Speed climbed past 400 kilometers per hour. The radar altimeter counted down. 100 meters, 50, 20, impact. The nose fuse sensed deceleration exceeding 10,000 Gs and detonated the 87-kilogram PBXN-109 warhead milliseconds later. Pressure at the impact point exceeded 4 million psi, shattering reinforced concrete designed to withstand a fraction of that force. An 8-meter crater tore open where the spillway met the dam's main body. Cracks raced outward along construction seams. 30 seconds later, water pressure found the weakness. A 15-meter section of the spillway collapsed inward, and 12,000 cubic meters of water per second burst through the breach, ripping concrete away like paper. The river surged downstream, overwhelming control systems and flooding everything below. From low over the river valley, the Su-27 pilot watched the plume rise in his mirrors. No celebration, no radio calls. He rolled wings level, dropped back to the deck and disappeared into the terrain, just another shadow in the valleys. Behind him, the dam was failing, and for the first time that night, Russian operators understood the truth. They hadn't lost a missile exchange. They hadn't lost an aircraft. They had lost the target.